Hello friends, in this video I am going to explain the part modeling and assembly of sleeve and cotter joint using Creo 7.0. Now let's see the different parts of a sleeve and cotter joint. Here you can see the sleeve, which is a hollow part with uniform cross section. This sleeve is used to connect two such rods with the help of cotters. We need to insert the two rods, one onto the left of the sleeve and the other on the right hand side of the sleeve. So these rods can be connected with the sleeve with the help of two cotters, so that the sleeve and the two rods along with the two cotters will form sleeve and cotter joint. Now let's see the various features of sleeve and cotter joint. Sleeve and cotter joint is a type of joint used to connect two similar coaxial circular or square rods. And the cotter is having a rectangular cross section with uniform thickness but with varying width. One end would be a straight end, but the other end is a tapered end. The slots which are present on this sleeve as well as rod are made slightly larger than the size of the cotter in order to promote the wedging action of the cotter. Cotter joints can be quickly assembled as well as dismantled. One of the main limitations of the cotter joint is it does not permit any angular misalignment between the cylindrical rods. Here you can see the details and dimensions of the individual parts. We need to assemble all the parts together to get the assembly of sleeve and cotter joint. Now let's model the parts of the sleeve and cotter joint. First let's consider the sleeve, which is of inner diameter 25 mm and outer diameter 44, and the total length of the sleeve is 150 mm. Let's open a new file in Creo 7.0. Change the file name into sleeve_001. Remove the tick mark on use default template. Give OK. Select MMNS part solid absolute. Give OK. Select the right plane. Go to extrude command. Click on the sketch view. Switch off the icons in the view toolbar temporarily. Once again, let's see the dimensions. We need to draw the sleeve of inner diameter 25 and outer diameter 44 and a total length of 150. Go to sketch option. Draw the center line. Now go to circle command. Select circle and point. Draw the concentric circles. We have to change the inner diameter into 25 and outer diameter into 44. Click on the refit. Give OK. Slightly tilted. You will get some idea about the extruded part. We shall keep the plane of extrusion at the center and the length of extrusion is 150. Give OK. Now we have completed the cylindrical part of the sleeve. We shall switch on the reference planes. Now we have to create the two slots in the sleeve. So if you see this particular assembly diagram, we can understand that we need a clearance of 3 mm at the top and bottom region of the sleeve. Instead of creating the grooves directly, we shall draw the cotter with 3 mm extra width to accommodate the clearance and then extrude the part. Go to standard orientation, go to model, select extrude, select the front plane, select the sketch view. Now we shall include the reference lines at the left end and the right end. Close. As I have mentioned, instead of creating the grooves, we shall draw the cotter directly and then remove the material, so it will become the groove. So go to line, Draw the cotter. Now we have to give the dimensions. Considering the 3 mm additional width for clearance, we shall give the upper width as 28 plus 3, 28 plus 3, and the bottom width is 25 plus 3. Half the length of the cotter is 32.5 and the total length of the cotter is 65. The slot is located 25 mm from the left end. So this gap is 25 mm. So let's once again check. The width of the cotter at the top should be maintained 28 plus 3 and the bottom width should be maintained 25 plus 3 considering the clearance, and it is located 25 mm from the left extreme end of the sleeve, and the total length of the cotter is 65 mm. Half the length of the cotter is 32.5. Now give OK. Center line 8 mm and we need to remove the material. Give OK. Now we have completed the first slot on the left. Instead of creating a new slot on the right hand side of the sleeve, we can mirror the slot so that we can get the new slot on the right directly. Select the extruded part, go to mirror option, select the central plane so that the part is being created on the right hand side. Give OK. Now we have completed the sleeve part with 2 slots. Let's save this. Save a copy. Okay. Let's close this part. Moving on to the creation of the next part of the assembly, that is a rod. There are 2 rods in this assembly, both are of same dimension. Instead of modeling 2 rods, we can model a single rod and use the same rod for the second time. Let's model this rod. The dimensions are 25 mm diameter for a length of 53 plus 35, that is 88, and its diameter reduces to 22 for certain length. So let's open a new file, part. We shall rename it as rod. Remove the tick mark. Give OK. Select the millimeter, Newton, second, part, solid, absolute. Give OK. We shall draw this rod from the right plane. Okay. So select the right plane. Give extrude. Select the sketch view. Go to view option. Switch off the reference plane. Go to sketch option. First draw the center line. Go to the circle command. Select center and point. Draw the circle. The diameter of the circle is 25. Change the diameter into 25. Give OK. Change the direction of extrusion towards left. and the length of extrusion is 53 plus 35. 53 plus 35. Give OK. Select the standard orientation. Now we have to extend the rod with the diameter of 22 mm. So select the extrude, select the plane, select the sketch view, draw a circle with center and point, and the diameter is 22. Change the diameter into 22. Give OK. Assume the length of this portion is 25. Give OK. Okay, now we have completed the rod, but the slot to be drawn. Now we have to create the slot. So go to view, switch on the reference planes, go to model, select extrude, select the front plane, click on the sketch view, include the reference, close. Now we have to sketch the slot. While creating the slot inside the rod, we need to provide a clearance of 3 mm. Let's draw the sketch of the cotter. The total length of the cotter is 65. We should keep the slot at a distance of 35 mm from the left end of the 25 mm diameter region. So change this value into 35. Half the length of the cutter is 32.5. We have to dimension the top region, which is 28 plus 3. Okay. So we are including 3 mm to accommodate the 3 mm clearance. And the bottom width also should be 25 plus 3 mm. Here also we are considering the 3 mm clearance. Okay, now we have given all the dimensions. The bottom portion is 25 plus 3 mm clearance. The width of the cotter at the top is 28 mm plus 3 mm clearance. And the total length of the cotter is 65 mm. And the cotter is located 35 mm from the left of this reference line. Now give OK. Extrude it centrally. And the thickness of extrusion should be 8 mm. And we need to remove the material. Okay, now we have created the part. Select the standard orientation. We need to provide a chamfer at this particular region. So what we can do is select the chamfer command. Fortify into D and give a length of chamfer as 1 mm. Select this curved region. Give OK. Now we have completed the modeling of the rod. The color of the rod also can be changed with the help of the view option. Go to appearance. You can select a light color. Select the part. Okay, click on the part so that the color of the part can be changed. Click activate. Now save this file. Save as, save a copy. We can give the name as rod underscore 002. Q OK. Now let's close this model. The only part we need to model is the cotter. So we know the dimension, it is 28 and 25. The length is 65. The thickness is 8. So we'll start a new file, part. We shall give the name as cotter. Remove the tick mark. Give OK. Select the millimeter Newton second part solid absolute. Give OK. Select the front plane. Select extrude. Sketch view. Go to view option. Switch off the reference planes. Go to sketch option. Draw the center lines as a reference. Go to line chain. Draw the cotter. Okay, we know the total length of the cotter. We know half the length of the cotter. We know the bottom width. We know the top width. Okay, now we need to change the dimension to the given dimension. So select the part. Go to modify dimension. Remove the tick mark on the regenerate. We know the top width is 28. The bottom width is 25. Total length is 65. And half the length is 32.5. OK. We have created the cotter with the upper width of 28, bottom width of 25, total height of 65, and half the height is 32.5. If we refer this cotter diagram, there is a curved region, so we can also create that curved region at the top and bottom. The radius of the curved region is not given. Let's assume certain value and proceed. Okay, we shall assume this value as 40. Same way we shall draw another arc at the bottom. Here also we shall maintain the same radius 40. We shall remove the unwanted regions using delete segment. Give OK. So we shall keep the extrusion symmetrical, and the thickness of extrusion is 8 mm. Give OK. Let's change the color of the cotter. Select the part. Okay, it has been changed to red. We all know that the right end is a tapered end. In order to differentiate the tapered end, we can change the color of this particular surface. So go to appearance, select. I have selected green color. Select the surface and give the green color. Activate. Now we can save the file. Save as, save a copy. OK. Now we have finished the modeling of all the three parts. It's time for us to assemble the modeled parts. Open a new file. assembly. We shall change the file name as cotter underscore ass 001. Remove the tick mark, give OK. Select MMNS ASM design absolute. That is millimeter Newton second assembly design absolute. Give OK. We shall select the sleeve part first. Give open. Define this part as the default part. Give OK. The first part is ready for assembly. Let's switch on the planes and the reference lines so that it will be easy for us to assemble. Now we shall insert the second part for assembly. Select assemble. Select the rod 002. Give open. We shall move the rod in this direction. First, let's ensure the axis of the sleeve and the axis of the rod are coincident. Select the axis of the sleeve and the axis of the rod. So both are coincident now. Next, we should prevent the rotation of this component with respect to this horizontal axis. So select this top plane and the top plane of this assembly so that both will become coincident. Now we have to select this side plane, okay, side reference plane, and select the middle plane of the sleeve. Keep the distance between the two planes as 0. Give OK. Now we have assembled the rod and the sleeve. We can notice a 3 mm gap between the slot of the sleeve and the slot of the rod. Instead of assembling the second rod on the right hand side, we can directly select the rod and go for mirror option with respect to the center plane. Give OK. Now we have assembled the right side rod into the sleeve. Here also we can see the 3 mm gap. Let's change the orientation to standard orientation. Now we have to assemble the cotter into this assembly. So go to assemble, select the cotter, open. Let me take it to the left. Let's arrest the vertical movements. So select the middle plane of the cotter and the middle plane of the assembly. Okay, so that the vertical movement can be arrested. Now we have to make the middle front plane and the front plane of the assembly to be coincident. Now we have to arrest this horizontal movement of the cotter. So we have to coincide this particular surface with the left surface and keep this distance 0. So the distance between the two surfaces are made 0. Give OK. Instead of assembling a new cotter separately, we can go for mirror option. Select the cotter. Go for mirror option. Select the middle plane. Give OK. After assembly, we should ensure that the tapered region, okay, we have shaded with green color. Those regions should face the middle part of the assembly, and we should ensure the gap of 3 mm between the cotter and the sleeve at the middle region. Okay, here we can see a gap of 3 mm, and also this side also it is 3 mm gap. And there should be another 3 mm gap between the rod and the cotter. Also on the left hand side, we should ensure a clearance of 3 mm between the rod and the cotter. Now we have successfully completed the assembly as per the dimension. Thanks for watching this video. Hope you have enjoyed. Don't forget to like this video, share it with your friends and subscribe this channel.